This is a list of all of the stuff that needs to be memorized, not just for the Trig 101 quizzes, but for everything that we're doing this year. In general, these things are going to keep coming up over and over, so we want to make sure that we know them really, really well. The first is SOHCAHTOA, which we talked about a little bit the other day. Just as a refresher, this is just our shortcut for remembering what the ratios are for the sine, cosine, and tangent ratios. When we have a right triangle, all of the ratios, sine, cosine, and tangent, are named in relation to one of the non-right angles, so one of the acute angles, okay? So from this angle, this is the opposite leg, this is the, come on pen, this is the adjacent leg, and this is the hypotenuse, okay? So I'm going to call this angle A. So the sine of angle A, or the sine of theta, if we want to use the measure, is equal to the opposite leg over the hypotenuse, okay? The cosine of the angle, or angle A, is equal to the adjacent leg over the hypotenuse. And then the tangent ratio of the angle is equal to the opposite leg over the adjacent leg. Even if or no matter what piece of your expression or your equation is missing, still write the full equation like this. So even if we're missing the angle, still write the equation sine of that angle equals, and then the ratio of your opposite to your hypotenuse. And then you can solve based on whichever piece has the variable. So for example, if, let's say, this thing, okay. So let's say that this was my unknown, and I was looking for, and I was given that this was 10 and that this is, I don't know, 40 degrees. I would write the equation. So from this angle, this is the opposite leg, this is the hypotenuse, so that tells me I'm using sine. So I would write my equation as sine of the angle is equal to the ratio of the opposite side over the hypotenuse, and then do whatever algebra is necessary to solve for x. If the angle is the thing that is missing, then I would write sine of theta equals, and then I would have my ratio. To undo a trig function, then in my calculator, I'm using the inverse sine, cosine, tangent, whichever is appropriate, because the thing to remember there is if the, let's see, so let's say we have sine of theta equals 5/7, okay? So when I apply a sine inverse to this whole thing, I'm undoing that sine, and then I have that theta is equal to sine inverse of 5/7. So if I know the ratio, okay, and I'm looking for the angle, I need to plug that into an inverse trig function. And if I know the angle and I'm looking for part of the ratio, then I'm using the straightforward sine function, or whichever trig function it is. Okay, reciprocal functions. So reciprocal functions, we know that secant, whoops, come on, pen. Secant is the reciprocal of cosine. I'm just going to use a theta here. Secant of theta is 1 over cosine of theta. Cosecant of theta is 1 over sine theta, and cotangent of theta is 1 over tangent theta. Since tangent theta is sine over cosine, not a reciprocal function, but still an identity that we need to know, comes up frequently. So tangent is equal to sine over cosine, then cotangent is also equal to the reciprocal of that, so cosine over sine. Okay, and then for our special right triangles, there are 2 of them that we need to know. So one of them is the 30, 60, 90. Okay, so 30, 60, 90. And then the ratios of the 3 side lengths here are 1 to root 3 to 2. Okay. Something to clarify, because just based on the way that I saw this on the Trig 101 quiz that you took today, not all 30, 60, 90 triangles have side lengths of 1, root 3, and 2. What this means is that the 3 sides are in a ratio of 1 to root 3 to 2, because that's what the trig functions are about, is they're all about ratios. In other words, if the hypotenuse of the 30, 60, 90 triangle is 10, then that means this short side is going to be half of that, or 5, not that it's going to be a 1 and a root 3. Okay, so just to clarify, even though we label it 1, root 3, and 2, just keep in mind that those are ratios, so you might have to multiply by something if you're actually looking for a side length, okay? All right, and then the other one is the isosceles right triangle, which is a 45, 45, 90 triangle. Okay, both of these are the same, so the angles are the same. And then the side lengths have the ratio of 1 to 1 to root 2. Same thing. Again, they're ratios, so obviously if this side has a length of 9, then this one is the same, also 9, and this one is root 2 times that, so 9 root 2. Okay, so both of those need to be memorized. To help you remember the order of where to put these, remember that the shortest, on any triangle, the shortest side has to be across from the smallest angle. So if this is my 30-degree angle, the shortest side is 1, okay? And then the middle side is root 3, which is about 1.7. That's across from the middle angle. And then the largest side, the hypotenuse, is across from the biggest angle, which is 90. Okay, for quadrantal angles, you may have been taught this from using the unit circle, and if you are familiar with that, that's fine. So if we're thinking about the unit circle here, let's see if I can draw, oh, it's an okay circle. Okay, so this point is the point 1, 0. This is the point 0, 1. This is negative 1, 0, and 0, negative 1. And if you want to use this, this is fine. If you are doing this, remember that your points, the coordinates for the points are cosine of theta of that angle and comma sine. Okay, so what that means is if I'm looking for the sine of 90 degrees, which would be the angle that goes from here up to here, then I'm looking for the y coordinate, which is the 1. Okay, I know I have graphs written with a question mark here, but as I'm making this, I remembered that you haven't learned those graphs yet, so ignore that. We will come in a chapter or so, at some point, we're going to learn what the graphs of those look like, and it will give us maybe a little bit easier way to memorize the ratios for the quadrantal angles, which are at the right angles. But for now, we need to know the points on the unit circle. Okay. And then for signs of ratios, you have seen this before, ASTC, or we say all students take calculus as a mnemonic device to help us remember that. But what those represent is which of the 3 original trig functions, sine, cosine, and tangent, are positive in each of these quadrants. So all of the sine, cosine, and tangent ratios are positive here. Sine is positive here, meaning cosine and tangent are negative. Tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So you can memorize it that way. Or the other thing that you can think about is just think about ordered pairs. So if I have a point on my unit circle, nope, that's a terrible circle. So I draw the circle first. Okay. So if I have a point on my unit circle right here, let's call this XY. And I draw a little reference angle, okay? Both the x and the y coordinates are positive because we're in quadrant 1. Okay, well, I know that this is a positive x value, this is a positive y value, and this, which is 1, is always positive because the radius is always positive and has a length of 1. Okay, so I know that all 3 ratios, whether I do y over 1, x over 1, or y over x, okay, or any of the reciprocal functions, all of them are going to be positive. All right, but then think about what happens if I'm looking at a point that's in quadrant 2, like this right here. Oops. Sorry, I can't draw a very straight line with this pen. Okay, so this point right here still have the coordinates x and y, but now x is negative and y is positive. Okay, well, from the reference angle, which would be this right here, let's make that bigger. Fix that. Okay, so from this reference angle, this is y, this is x, this is still 1, the radius. My sine of the angle would be y over 1. Y is still a positive number because this point is above the x-axis, so I have a positive over 1. That means the sine ratio is positive. The cosine ratio, however, from this angle, the adjacent side is the x-coordinate, and this is a negative value. Okay, so if I have a negative side length here divided by 1, I'm going to have a negative ratio. And then similarly, if we are in quadrant 3, Okay, any point down here. All right, so here's our reference angle. Now both x, this distance here, and y, both of those are negative. So if x is negative and y is negative, and then tangent is the y coordinate over the x coordinate, okay? I've got a negative number over a negative number, then that's going to give me something that is positive. And then lastly, if I have a point over here, I'm looking at a positive x value, a negative y value, so sine is going to be a negative number over 1. Okay, so sine is negative. Cosine would be x, a positive number over 1, so cosine is now positive. And then tangent would be a negative value over a positive, so it's also negative. So that's why cosine is positive in quadrant 4. So if I am trying to find, or trying to evaluate a ratio of one of these angles, either a multiple of 30 or 60 or 90 or 0 or 45 in some quadrant, I don't have to memorize all of them. I don't have to memorize the whole unit circle. The things that I really need to know is I need to know what sine for 30, 40, oh, should have put 0 here first. 0, 30, 45, 60, and 90 are, and then also cosine for the same. And if I can memorize those, I can get to all of the other ones. Now I need to be pretty fluent with these, okay? Fluent meaning I can do them with speed and accuracy and flexibility. So I need to know these, like these need to be memorized. If I can memorize those, I can get to all of the other ones pretty quickly, okay? So for example, if I'm looking for the, I've got an angle, let's say 135. Okay, so 135 degrees, and I'm looking for the cosine of this angle. Okay, what I need to know is that it's in quadrant 2. Okay, in quadrant 2, the reference angle here would be 45 degrees because the rest of the way down to 180 would need to be 45. So now I'm thinking 45, 45, 90 triangle. Okay, and then I know that the cosine of 45, based on this triangle right here, cosine is 1 over root 2. Okay, so cosine, so I'm thinking about the ratio 1 over root 2. And then in this quadrant, I need to ask if sine or if cosine is positive or negative. Well, if I remember that sine is the only one positive in quadrant 2, then I know that this is negative. My other thing that I can remember is since I have a negative x coordinate, okay, this is a negative value over a positive radius, because radius is always positive, then I know that that ratio needs to be negative. So my answer is negative 1 over root 2. Okay. The last thing is there's a shortcut. I don't know if I call it a shortcut. Something that might help you since you're going to be answering a lot of questions on the test involving these ratios. If you can memorize this little chart, then you can like quickly draw it at the top of your test and then use that to answer a lot of your questions. Sorry, I'm about to run out of time, so I'm going to fill the chart in for you. Okay, so pause it if you need to and copy this down. But the idea here is that the angles that I listed up here in order are 0, 30, 45, 60, and 90, okay? And then for sine, actually for all of these, notice that they're all fractions with a denominator of 2. Also, I put radicals around all of my numerators. So I've got the square root of 0, and then I increase square root of 1, square root of 2, root 3, and root 4. Now, can those be reduced? Obviously, yes. Should I reduce them? Definitely yes. Okay, so really, I should just have 0 here, and then square root of 1 is 1, so that's 1/2. Root 2 over 2 we can leave like that. Root 3 over 2 we can leave like that. Square root of 4 is 2. 2 over 2 is 1. So yes, I should reduce those, but for filling out the chart, just remember root and then 0, 1, 2, 3, 4. Cosine, because these are cofunctions, and 90 minus theta on sine gives us the cosine value. It's the same thing, except we start at 0 and increase this way. So this one is 2, that's root 3 over 2, root 2 over 2. This is just 1/2, and then this one is 0.